All right. Hi, everyone. Welcome to the. I'm sorry, I've messed up the date. This is lesson 6 meetup for our Fast.ai deep learning group. Can you guys hear me okay?
Yep.
Awesome.
Yep.
And my screen is visible, right? The slides are visible to you?
Yes, they are.
Awesome. So today we'll be covering the the sixth lesson of the deep learning move. And we have a lot of things going on in the sixth lesson, which we'll cover. So this is the agenda for today's meetup. And
sometimes.
so today is our
No,
third to the last in our first cycle. And about a study group, this is hosted by the TWiML AI community. And if you're here, you're probably from the Slack group. If you aren't, please go ahead and join the Slack community. So this will be in the format of weekly Zoom meetings where we'll go over the lessons and discuss interesting things that we've been working on. And we're doing rotating hosts. So today I'm hosting the meetup. So please blame me if anything isn't correct. Another minor detail, there'll be a gap in the Fast.ai lesson because the team is going to New Rips, the New Rips conference. And we'll still host the meetup on the 8th of December. So a few things that I want to talk over the lesson 6 are platform.ai. It's I think Jeremy's new company that he's co-founded. Also, he does a deep dive into CNNs along with a quick sale prediction challenge. And they do spend some time in ethics and data science. So if that's something that you guys find interesting, we could probably take that up. And platform.ai is something which I personally found very cool. One use case is probably it allows you to label your data very easily. And the first use case that comes to my mind is you could easily go from unsupervised learning into supervised learning by just uploading your unlabeled data set and then labeling it and quickly downloading the labels, and then you could do all sorts of activities with it by things we already know. So definitely something worth checking out. And I think it's for free as long as your data and models are public. So again, it's great. And after that, Jeremy discusses the Rossmann source challenge. Basically, it's about prediction the store sales. And the metric is root mean squared percentage error. Again, a quick math term if you want to go into the details. So the challenge is to predict sales, and the evaluation metric which I just showed to you. It's similar to root mean squared error, which we're already familiar with, except it's calculated in percentage, which obviously because you want to know how different is your percentage in terms of the prediction rather than just the absolute value. So that might make sense. And apart from that, a few things that I found interesting in the lecture were Jeremy discusses preprocessors. So these are similar to the ones we're familiar with, image processing ones. And these are specific to the categorical and in general tabular data. So categorify is something that takes in your variables and turns a continuous one into probably categorical. And you also have the fix missing, which basically replaces it with the Boolean value, or you could replace it with the median value. Or what Jeremy has suggested, you could probably do both and let your neural net figure out what is better. Another thing is you want to have a wider range for prediction. So what they do in the lecture is they multiply the target variable by 1.2. And after that, they quickly go over dropout and drop out in embedding layers. So dropout, basically what it does is it randomly, it's a hyperparameter, the value that you choose based on that probability, the activations, they deleted at random from your neural nets weights. And the main cause for, or the main reason for doing this is you want to avoid overfitting. And sometimes your neural net might overfit to something, so you don't want any specific weight to overfit to anything. So that's something dropout comes in. And then there's dropout in embedding layers. So the summary of that is dropout in embedding is done at the end instead of the middle layers. Apart from that, there's also a discussion of batch norm, and there was a quick plug about how it was wrongly anticipated even by the creators of batch norm. And basically, all you need to know is that it smoothens your neural net training. Any questions so far? Anything you guys want to discuss?
I thought fix missing was that they would add, I guess, two columns. One would be true or false if something was missing, and then another column for the median, so that the median would not alter the results.
Yes,
That's not what I thought you said.
That's right. And
Okay.
the reason for the same is you give more data to your neural net and more choice to it to pick up and learn from. That's what I understood from the lecture.
So basically it did gap filling, right, with the median. So they, whenever there was a missing value, they placed the median, but also marked it in an additional column. That there was
median along with the Boolean values of
exactly.
whether it's, yeah.
That's for continuous data, but then for categorical data, it just I'm not sure what it does for categorical data. I think it just leaves it as its own category. Missing is its own category.
Or you probably have the default -1 value in pandas.
Yeah.
So, yeah.
Mm-hmm.
So moving ahead. After that, there's a deep dive into convolutional neural networks, where basically the target is to replicate the heat maps of a cat image from scratch. And in the same lecture, various transforms are covered. And these happen out of the box inside Fast.ai. You just need to pass the hyperparameters. And these include affine, brightness, contrast, and a few all sorts of rotations that happen. So you could just go into the docs and look into them. And there's some general information that where you might want to rotate an image upside down, or you might not, depending on your use case. So be careful about that. And where you might want to adjust the brightness and contrast depending on your data set. So that's something, again, you'll have to play and figure out. So in the attempt to make heat maps from scratch, Jeremy goes over matrix multiplication, like in extreme detail, how matrix multiplication goes on. And then he goes over a blog post where it's nicely explained. I'll share the link after the meetup. After that, he explains what a convolution is via the setosa.io website. I'll again share the link. So basically what a convolution does is it's a matrix of 3 by 3 or 7 by 7. These are the general sizes preferred. So you basically convolve over your dataset image to produce activations. And this is done with multiple filters, and you get essentially another layer over which you again convolve. And these filters are explained in detail. So once you have the images up ahead, basically what happens is, since you're matrix multiplying, the size of the image, it gets reduced eventually. And you'll have an image that's maybe smaller in length and breadth, but it has a high depth to it. So what we want to do with that is we do pooling, or we take the average across the depth instead of the length and breadth, because we have more data across the depth. And towards the final layers, more knowledge is stored across the layers in depth instead of length and breadth. So we take average pooling, which basically gives the information and something that we might be interested in. And after that, there's a quick mention of hooks, which is something specific to PyTorch and obviously Fast.ai. So hooks in essence allows you to hook inside of PyTorch. And
sorry, before you get into hooks, just a couple of simple questions around CNNs. I thought I understood CNNs until I watched this video. But you know, like if you have a matrix that's say 3 by 3 by 3, and then you have another one that's another dimension, how do you know what size that resulting matrix is? So I get it for when you have a 2 by 2 and a 2 by 2, and I covered that in like high school maths. I don't know what happens when you have a 4 by 4 by 4 or 4 by 4 by 4, and then you have another 4 by 4 by 4. What's the resulting matrix size? And is there like a general formula, and how do you think about stuff like that? Because I think a lot of so especially when it comes to the CNN stuff, a lot of that is this kind of stuff, and it just blew my mind when I found it was actually multiplying by a cube.
So my approach to that is basically the fourth dimension. It's the number of training examples. So I would just not consider them, maybe take one example after the other, and then go ahead and figure out from what I know how things are working, and then extend it to the other examples as well.
So as far as I remember, you're asking about more than two-dimensional matrix multiplication, right?
Yeah.
So how do you multiply? We know that 2D by 2D multiplication is you take the rows multiplied by the columns, right?
Yeah.
So for the 3D, you'll do the same, but you take it layer by layer. So you have a 3D multiplied by 2D. Then you just take the first matrix, 2D matrix, and multiply by the other 2D, and this will generate a 2D matrix, right? Then you take the second 2D matrix, multiply by 2D, will generate another matrix, and so on. So you just slice it. Yeah.
Sure. So if you're let's say if you're multiplying a cube by a cube, do you get a cube as a result?
Oh, I don't remember that.
No, I'm not. Because that's the example he gave, right? He said you've got this thing and it's a cube and it's going through all of these things. So if you've got a 3 by 3 by 3 by 3, right, or whatever, 5 by 5 by 3, and then you're multiplying it by a cube, which was say 3 by 3 by 3. What is the size of my resulting matrix? So I don't know, because
yeah, I don't remember that. Yeah, good question.
So you have to take a slice, because what Haider is saying is you take a slice of the matrix and make it it's a two-dimensional problem, and then you just do it in parallel for all the other slices. So you do it the same way with 3 by 3 by 3. The other matrix, its slice, it gets multiplied by a slice of the 3 by 3 by 3. And the outcome of that slice is dependent on the dimensions of the matrix. I mean, it's the point, bottom line is that when you multiply a three-dimensional matrix by another three-dimensional matrix, you're going to get a cube. It may not necessarily be a cube, but it's going to be 3 by n by m. It's going to be some three-dimensional parallelepiped, or not parallelepiped, but a rectangular-looking matrix. Maybe not a cube. But you're doing it slice by slice, and when you take a two-dimensional slice and multiply by another two-dimensional slice, the dimensions of those slices determine what the product is going to look like. In other words, if you had 2 by 7, multiply 2 by 7 by 7 by 3, then you're going to get a 2 by 3.
Yeah, but that's easy though, right? Because you're talking about 2D by 2D, and like everyone learned that at school.
Yes.
But when
yes.
it becomes bigger, then
yeah, you do it by slices, like Haider was saying.
Okay. Okay.
So yeah, you break it down into two-dimensional multiplications.
I mean, the reason for breaking it down is basically when you're looking at 3 by 3 by 3, in essence, it's because you have RGB values, right? So
yeah.
just consider one channel. So you have a 2 by 2 matrix, right? Let's go to the 4 by like the 4D problem where you have 4-dimensional thing. The 4th dimension is your number of training examples. Let's discard that. Let's just look at one example. So now you have a 3-dimensional matrix, right? Which is because you have RGB channels. Now let's just look at red channel for once, and you're running a filter on it. So you just have one filter on one image, which is a 2 by 2 matrix and a 2 by 2 matrix, right? I'm talking about the dimensions. So from there on, I think it's easy to visualize.
Okay, yeah, I mean, I think it helps to think about it in terms of slices. I'll try to do that, yeah.
I mean, there's some intuition behind why we want to slice it, because each dimension, it represents something, so that might help.
Okay, great, thank you.
There is a link, but I did not read it yet. I'm searching about the answer to this question, so I will just share it in the.
Someone has already shared a link. Maybe that might help.
Oh, I see. Yeah, the CM link. I think this is from the forum of Fast.ai. So yeah, maybe we can read this link later. Yeah. Even there is an answer for a simple for loop. There are 3 for loops, and how they multiply and then generate the 3D matrix as a result. So maybe we can tinker with it after the lesson. But it's a good question, really. I didn't thought that I have to understand this also. Yeah. By the way, I have a question regarding the transforms. When I try affine, brightness, contrast, and those things, they are working fine. But when I make a maximum zoom 1.1, more than 1.1, it fails with an error. Anybody of you guys tried maximum zoom, changing those numbers?
I was running 1.2 in the Doodle challenge. I think that was working okay for me.
Oh, I see.
I'll check again.
So, For the lesson 3, the regression, you remember the center point regression problem. I tried it. Anything more than 1.05, it will fail. So I don't know why, but anyway, maybe the other transformations, the affine, the warp, making the dimensions more than a certain limit. The error was about the dimension size. It says that the dimension is not matching. So at epoch 4, epoch 5, it will fail. Anyway, it's not a big deal, but I thought.
I haven't seen this either.
So, right. Sorry, another question I have is, you were saying that, you know, when you have a stride of 2, then you double the number of kernels. And I couldn't see how that was happening from the example he was giving, I mean, from his diagram. Was anyone else able to figure that out?
I think he's just adding the kernels because he's going to reduce the number of pixels per layer. So then
you're just saying he just creates twice as many kernels because he's got a stride of 2 rather than it's a result of anything else.
It's just as far as I know, that it's just a rough rule of thumb that whenever you are decreasing the resolution of your feature map, then you have to compensate that with increasing in the kernel depth, the kernel size. The idea of the kernel is that it stores the features of higher abstraction from the image. So, for example, in layer 3, layer 4, maybe you are taking from the image the eyes, the shape of the eyes, the mouth, the hairs. So those complex features are stored in each part of this kernel. So whenever you're decreasing the resolution, you have to compensate that with the number more number of features. Yeah.
Okay, great. Thank you. That's helpful.
And the other reason is you want to fit it into memory. So that's why we do stride 2D in the first place, I suppose, to avoid the memory constraint issues.
So also a question on the transforms. How to switch off transforms at all? How not to use them? Is there an easy way to do it? Or do I have to set them as kind of not transforming the image?
Don't you have parameter options that you can just say turn them off and do false?
For the default, there are certain transforms that will be applied. It's mentioned in the docs of Fast.ai. If you want to turn it off, you have to zero everything or none, or make the maximum zoom 1, and so on. So you have to do it manually. Yep.
I was thinking the same way, but I was hoping there's a like turn off everything, because this is also the Google quick draw competition, because there's so many images. Some discussion on the forum that you don't need any augmentation because you have like 50 million of images. That's more than enough. So basically, I don't want to do any transformation.
Not to mention, you just have 4 days remaining for that.
What's that?
You just have 4 days, I suppose, remaining for the competition as well.
I know. It's not much time left. Yeah.
And like the last point I want to discuss is Jeremy takes up hooks, which is something that allows you to add code inside the PyTorch machinery, so to speak. That's again something that I find interesting, and I'll explore this week. And apart from that, these are all the points I wanted to discuss, because otherwise it's just math and the details, and I suppose I cannot explain them in a better way. And if you want to discuss any other thing that you might, I'm happy to take it up.
Okay, so just one other thing, and I might be getting these confused, but up till this point, max pooling was always like the recommended approach for, in your CNNs. So I was quite surprised when he mentioned the average pooling, and he did average pooling in a slightly different way. I mean, am I making any sense? Because most CNN models always have max pooling rather than average pooling. Has that been your experience?
I'm not sure if this was in the same reference, but Jeremy had mentioned that in his personal experiments, the Fast.ai team found out that these few steps work out much better. So they've added a few things that they say are exclusive to Fast.ai. So this might be the same, I suppose.
Okay.
And if I remember correctly, they'll be taking that up in part 2 again. So I suppose it's something advanced. Too advanced for part 1 at least.
I think the adaptive average pooling, right? It's something Fast.ai related. The adaptive average pooling, right? The average pooling is pretty common in all.
Yeah, it's pretty. Yeah, it's nothing special about that.
Yeah, the special thing is the adaptive average pooling.
Yeah, I think that's what's in part 2.
Yeah,
I think
this was interesting to me. Well, it's not new, but I kind of didn't notice that initially. So when you lose that 1 pixel, so when you do the when you apply the kernels, and say 3 by 3 and you are on the edge, so you're going to lose 1 pixel. So I said, so what's the deal? Just 1 pixel is not really interesting. But then if you think about it, if you lose 1 pixel per layer and you have 100 of layers, then you're going to lose 100 of pixels by the time you get to the last layer. So that's why I've noticed it's important to add that padding on an image. So whether it is 0 or whatever, so you don't lose that pixel. So then you keep the same resolution. So something that I've kind of never paid attention to, but makes sense for sure. So what he mentioned, there are a couple of different methods. You can add zeros around the image, like a border, or you can do like a reflection. And I think Jeremy said that the reflection works best. It kind of reflects the existing image to the added padding.
Yeah. So, but surely with the reflection,
I'm not sure what's by default. I think by default it's got zeros, right? I'm not so sure.
Yeah, I think it is zeros. So, and he mentioned reflection, but he didn't get into any details. But surely when you're doing a reflection, you're adding more than just a border yet, right? You're probably adding a whole load more. But I wish you'd gone into a little bit more detail of that. Was anyone else? Did anyone else experiment with reflections?
I'm not sure exactly how they do reflections, but I think that what I think they might be doing is trying to match the mean brightness in the pixel with the other side of the image, so that there's kind of like a smooth, so that the edges have the same average pixel value, something like that. I don't know though.
Yeah, sorry. My question was more around, surely, so in order to get a reflection, if you've got, pixel A, B, C, D, then you've got to have A, B, C, D, but in reverse in the other way. But yeah, exactly how far out do you go? As in, are you going A, B, C, D, E, F, G up? Or are you just, how far do you have to go up? Because with the zeros, you're padding with just a single layer of pixels, while as clearly with the mirroring, you're going a bit further out. And I wanted to know if anyone had experimented with exactly how far out you go as part of that padding.
I think you are referring to that if you do not make any transforms, then you will get just one line of pixels that is missing, right? Because of the padding. But when Jeremy says that it is making a mirroring of a good deal of chunk of pixels, that means that there are more than one lines missing.
Exactly.
That's because of the transformation, when you are making rotations or making maximum zoom and rotation affine, then you will get some missing big borders of missing lines. So that's why you see some large line of mirroring. I don't know if I understood your question. This is your question, right?
Yeah. I mean, what I meant was like when you do the padding, it's just a single line, right? Which is like a border around your entire image. Right. But when you do mirroring, obviously it's got to be more than a single line. Otherwise, you'd never recognize it as a mirror. So how big exactly is that?
Big until you fill the gap. So if you do not have any transform, then you have just one line in the border. You are mirroring it with just the next line. But if you have let's say affine or warp, which makes let's say the top of the image is smaller than the bottom. So in that case, when you are viewing some 2D plane in a different angle in 3D, so then you will get some larger border, right? That larger border, you have to fill it by mirroring, taking the step by step, line by line, and repeat.
So are there two padding modes? Actually, one is the kind of padding for the because we will lose, say, 1 pixel or more pixels, depends how big kernel is from layer to layer, and the other padding connected to transforms. Maybe there are two padding modes actually.
Yeah.
In the library.
Yeah. So I think Haider, if are you saying that you only use the mirroring when you actually are doing transformations or these affine shapes rather than anything else?
I don't know, but I think that the mirroring you will see it everywhere when you are doing padding or transforms, but it's not obvious for you because you have just one pixel lines. But when you are making warp, let's say, you will see an obvious mirroring. And I think when Jeremy claimed that this is the best way, it's most effective with those type of transforms. And just for the comment for Michael's comment that every layer is you are losing one line. That's true for padding, but in transform you just make the transform in the first layer. You will not repeat it on next layers, right?
Yeah, I was more thinking that you have like two padding modes. One will be, because if you don't use transforms at all, that's what I want to do. You would not even go through that adding, say, reflection or whatever, but you still need to add at least, say, for the kernel, for 3x3 kernel, you need to add one pixel padding around the image, not to lose that resolution. So I'm thinking I need to check that out if actually maybe there are kind of two padding modes. One which is connected with the fact that you use the kernel, and the other with the fact that you use transforms. But I need to check that.
It may or may not be true because you're just moving the kernel one pixel after the other. So you might just go from edge to edge. And that's also possible without padding because you're just having your kernel placed inside the image at the edge location, which is a 3x3 location. And then you're moving it one pixel to the right or downwards as you convolve it.
Yeah, but when you do that, you reduce the
pixel.
size. Yeah, you will lose it. So that's why you got to have padding.
Yeah.
I guess we'll have to check and find out then.
Yeah.
Also, I've written down this if it helps the matrix multiplication question. So is this visible? Or
it is. Thank you. Yeah.
Is it? Oh, that's
better now.
Yeah.
Yeah. So this is basically the 4D input matrix. Which basically these are the training examples or your batch size.
Just a note for everybody, just click on the speaker view. You will see full screen of Sanyam. Speaker view. All right.
Sanyam also changed the settings on his side. We can see him now.
I see.
Or if I keep speaking, it'll just be me, I guess.
Yeah, that's right.
So let's say we discard this for now because this is a batch size 1024. Now we're looking at a 3x3 matrix and a 3x3 filter size. And these are the RGB values, right? And you have 3 filters for each channel. Now, this is by essence the image size, and this is your kernel size. So now the problem becomes a 2x2 matrix multiplication question. And that might be easier to figure out. But again, you cannot do that simple high school formula that the dimensions get interchanged, or what we used to do that we replace M and N, because in essence we're taking strides across the image and there's a formula which I don't recall. And that's how you find out the size for this 2x2 matrix multiplication. And then this will happen 3 times, so with 3. And then you have the 1024 batch size. So I suppose this will be the final size of the tensor that comes out. Does it make sense?
That's helpful. Thank you.
And those are all the points that I had to discuss. So if you guys want to discuss anything else, please feel free now.
Has anyone found any helpful resources around the hook stuff? Yeah, I mean, you pretty much lost me there after the CNN stuff.
I did not do a deep dive into it. I just watched it, and I'll probably dig deeper later this week.
I think the documents of Fast.ai is still a work in progress. It's not detailed enough. Last time I tried to make use of callbacks for developing the Telegram notification. Actually, I didn't find that the documents of Fast.ai is enough for me. So I tried to find any working examples, and one of the students of Fast.ai made a good notebook, and that was more helpful than the documents. The docs lacking a working example for each argument. So for example, for the callbacks, it says that it takes this argument and this and this, and then quark, and that's a very vague. Because this quark, you can put something there, but it's depending on the child of your class and so on. So I didn't understand well until I saw an example from one of the students. I even read that Jeremy wants the help of people to, if you want to contribute, one of the way is to fill with examples. So I think this is a working, yeah.
Ida, could you share that notebook as on Slack or here? Because that might help with making more sense of these.
Yeah, actually, I can show it to you. It's available in the forum. Just 1 minute. I will try to find it out.
Apart from that, I was also discussing on the Slack channel that what we might want to do after our first cycle of the meetup is done. So in general, everyone is interested in taking up tagging competitions, possibly archived ones, because you don't have the rules against public sharing and all. I'm open to what do you guys think? What is the best thing to do after the first cycle?
I think your idea was a really good one. It's just time. But yeah, I think trying to apply this stuff will help far more than anything else.
But just to keep us motivated and on track, maybe we could switch to a bi-weekly meetup if that gives us enough time.
Yeah, there were a couple of ideas on the Slack, right? It was like weekly, bi-weekly, monthly, Kaggle, live, past, deep learning book. There was a lot of suggestions and ideas. And it's really actually what works for us, and so how to do it. So we can keep putting those ideas, and then, because we still have how many, 2 meetups, right? Next week, week after next. And then
and I suppose the last lecture will have a lot going in because there's generative adversarial network going on.
Yeah.
So you are more inclined to make it every 2 weeks, right? The meetup? Okay, go.
I suppose that would be better given the time constraints and all, because tagging competition themselves are pretty heavy.
Well, I think I'd prefer a weekly thing because it just helps you keep on track and just make. So I mean, yeah, that's a preference. Maybe you should just do a vote or something, or do a poll on your Slack or a Google Docs or something.
We could have a poll in the channel.
In case we go for a weekly meeting, I think the best way is to make the topics different every week. I mean, for vision tasks, for vision competitions, let's say if you have 2 or 3 competitions, then you make it the first week and the 4th and the 7th. So that if anybody is interested more with the vision, he concentrate on those parts. I don't believe that everybody can do weekly competition, but This way, I think the solution is. So do you see my screen?
Yep.
Yes.
I shared on the chat the link for this forum thread. So here there is a project. It's called Telegram. You can install it by. I will show you how. This is the way to install. Pip install Python Telegram bot. This is a library for Python to deal with Telegram. And this is the function to make the notification. The default is that job's done. If you don't want to make a notification for every epoch, how is your model how is your fit is going with accuracy, then this will be simple. Just notify me and it will send you a message that job's done. In case you want something like this, it gives you the train and valid and error rate. Then you have to deal with callbacks. The callbacks is as you define the class here, notification callback, and as you see here, the on train begin. This will be called when you start your training, and it will send this message, which is this one. And then with every epoch end, it will record the validation loss and the accuracy from this last matrix 0 and last matrix 1. This is something automatically recorded in Fast.ai. And for the training loss, you have to call the smooth loss.item. This one. This is the training loss. It's an average of several training losses happened before. It's smoothed out, and that's it. When you create your CNN, you pass. Sorry, for the fit. When you make the fit, you pass the callbacks here inside the fit one cycle. And that's it. And these are the details how to do a bot for your Telegram group. This group I created it with 2 person, me and the bot. It's a Jupyter bot, I called it. So they are just simple step-by-steps how to create those and pass your token into a file in the machine. And I think it's pretty easy to do it with those links. I think.
So you leave. You leave your computer running, and then you get notifications. Is that how it works?
Yeah. When I leave my PC, then I get the notification in my phone, or if you have a smartwatch, you will get the notification also. Yeah.
Nice.
Most of the time I use just the jobs done. For this one, not very important to check it every 1 minute, 2 minutes for the losses and accuracy. So it's okay to leave it. So just notify me, and that's all, and it will give you that jobs done. So you can switch back to your work. Especially if you are working with the GCP, Amazon cloud, then every minute is counted in the cost. Yeah.
Nice.
And if you have 2 GPU now, I'm trying to make 2 GPUs working together to accelerate the process. I have a lot of logbacks from lesson 3, 4, 5 till now. I didn't run, so I try to run more than 1 notebook at the same time. So I switch back and forth between them, depending on the notifications here.
Yeah, very nice.
personally, I utilize this to send me a message once the training is done, or I'd say a hacky script, so to speak, which notifies me when my GPU is not being utilized. And then I'll SSH from my phone when I'm in a lecture, and then put another task on training. That might sound interesting.
If you have a local machine and you can hear the sound, there's a simple way to make a sound beep from Python. There it is. There is some.
That's another way.
Yeah, I was doing that when I was working on my local machine. So for the Kaggle competitions, I suggest that we do maybe tonight I will make a spreadsheet, or let's say a Google task for arranging some suggestions about the competition that we choose, and later on you can add also, you can edit that document and add your favorite competitions, and then later on we make a poll to choose from every topic the highest voted competition. For segmentation, I have 2-3 competitions. For multi-class, multi-label vision, I have 2 or 3 competitions that I'm interested in. So I will make some Google Sheet or Google Tasks that you can edit. You can add your interested competitions, and then we can make a poll to choose one for each topic. What do you think about it?
Yeah. So the question, the idea is to rally the light, so competitions that are still open or the closed ones. So there are pros and cons, of course, of every scenario.
Yeah, good question. I think we should poll about this also. Christian prefers live competitions, right?
I'm not really sure, to be honest. I mean, like if you do a live one, for me, it's I kind of failed with a couple of them when I jumped like halfway in, because you know, with like 20 days to go or 2 weeks to go, it feels like, okay, you get started, you get the EDA kernels to figure out what's going on, and then it's like already forming teams and everything. It's kind of, if you can't really do it full time. So I would be happy to do a live one, but I would prefer something that just started, basically. So the Elo one I saw is super fresh. I'm sure if that's interesting.
Have recently launched, if I'm right. One is the Humpback, the Elo, and another is a Playground one, if I remember correctly.
Yeah. So either way, I mean, I'm happy to do interesting old ones, but if we want to do a live one, I would prefer one that's really new, and therefore there's more time to I don't know if others feel the same.
Yeah, I'm like you. I am most excited about new competitions, because it's, you know, the feeling that you are trying to compete with others and so on. So I think maybe if you agree, make one competition that is live, and it will take more than 1 week. Of course, we tried the best on this one. And let's every week try concentrate on past competitions, especially those that they have an example shown by a winner from our Fast.ai students. What I would suggest now, I try tonight to make for each topic the competitions that I have collected in the past 2 months. With those that win the competition with Fast.ai library. So
yeah, it would be good to have one close to the notebooks, you know, like topic wise as well. If there's something that we don't have to like invent some kind of model setup that wasn't one, therefore it's a lot of details, PyTorch details. But if there's something like the Rossmann or anything that's kind of similar, that's probably much easier to get going, right?
Haider, can I take this back to what you were talking about running on your computer? Are you using a CPU or a GPU?
For the GCP, for the Google Cloud?
Yes.
I have increased the quota. You have a certain quota that you are limited to. So if you increase the maximum GPUs allowed for you, within few hours they usually they will agree. Google will agree. So I increased it to 4 GPUs that I can run at the same time. So when you edit your instance, you click on the instance and then edit the processor type. You can assign how many GPUs you can assign for your instance. So I increased it to 2. Actually, my limit now is 4, but I feel very difficult to switch into 4 notebooks at the same time because maybe computers can work for 4 notebooks at the same time, but I cannot. So I'm switching just in between 2. Now I have 1 GPU is running lesson 3 IMDb, which took around 2 or 3 hours and still not finished yet. So in the meantime, I work on another notebook. Right now, my watch gave me notification that the planet competition has finished.
Do you run it from notebooks only? Because I had the problem with the IMDb one, or anything running longer than 4 or 5 hours, that I lose connection, and then it's hard to reconnect to the kernel. So I was getting really frustrated, and I kind of, for those, I basically did scripts and did command line models. But your notebooks and your connections are stable then?
Yes, stable. It just happened once. I think within before 1 week ago that they shut down my instance. That's because it is a preemptive, you know.
Yeah, I don't think I had the problem because of the preemptiveness. I think it's more that either my laptop goes to sleep or something funny happens, and then it just, I don't know how to. I think it was still going because the NVIDIA SMI was still showing memory and stuff, but I just couldn't reconnect to the kernel. So it's
one good tip is to use Tmax. Do you use Tmax? Once I closed my bash window accidentally, and then of course the notebook is telling me that you have disconnected. So I reopened the bash and opened my Tmax session, and everything is restored. It was fitting. So I missed 1 epoch, and that epoch has been shown because
maybe I should check it out. I thought it's like a Jupyter thing, but maybe it's really normally if I do scripts, I do no hub commands, right, and then send it to the background.
You didn't use Tmax, right?
For this one, no, I didn't.
This is the solution for your problem.
Okay,
Tmax
cool.
will save your session, and if you have disconnected, then within 10 minutes, 5 minutes, even half an hour, it will restore everything.
Okay, I'll give it a go.
I guess I could do a mini presentation in our next meetup on Tmax.
Yeah, I used it once, but I got confused. But maybe some intro again. Yeah.
The other idea that if in general you're running anything that runs for so long to train, you might not want to use Jupyter in the first place because you want to make sure you use every possible resource, and even Jupyter eats up that little RAM, or so to speak. So you just might want to run a script instead.
Yeah, I mean it's very few lines of code anyway, so I was just copy pasting the stuff in there. Yeah. By the way, is any one of you guys, it's kind of related, is using the Visual Studio Code with a new notebook edition?
I have one objection against this Visual Studio Code, and also about PyCharm also. The problem is that it's not easy to work on a remote computer.
Yeah.
But one solution that I found folks are speaking about is to use a virtual machine, VNC, sorry, VNC. This is something like a remote desktop sharing in Windows.
Yeah.
So they run the IDE, They run it on the server.
Yeah.
And then by VNC, you can work on that IDE. For the PyCharm, they have I think the professional edition, which costs money every year. I think $100 or something. You can work on a remote server, even though you will use the IDE in your client.
Yeah.
But I haven't used that.
I haven't used it myself. Yeah.
Yep.
It's a choppy experience. It's not the best thing, but it does the job if needed.
Okay.
I think the Visual Studio, they are thriving to make it better and better. Maybe this is something in their mind to make it work with remote servers.
Yeah, I mean, I'm a big fan of it for like just local Python programming. So it's a really nice editor. I just didn't really explore the new feature where you can basically import notebooks and have like this interactive thing going.
Are you talking about Visual
Studio Code?
Yeah, right, Visual Studio Code, because I was playing with that some time ago. And my only complaint is that it treated it as though it was just a Python program. And so the interface that we're used to, that's gone. So
I mean, there was this new addition that you could basically get live plotting within your editor, because basically Visual Studio Code is just an Electron, I think, JavaScript kind of thing. So they can render whatever inside of the editor. And apparently you can get basically the same interactivity like Jupyter, but with one source code file, not these kind of stupid boxes which totally throw me off all the time, because you have different states. And so you have like continuous source code, but you could get like bits and pieces. But I haven't tried it. I think Kai was experimenting with it, or he mentioned it, but I don't know. Anyway, sidetrack.
I had recently changed it and it was a little better, but it's still.
I'll probably have a go and report.
Where you don't like Jupyter, and actually I like the way Jupyter works. So.
Yeah, I don't really mind it. It kind of grew on me, so I was against it, but now it's okay.
Jupyter is very nice, but one drawback is how to use the debug. There is debug, the PDB.
Yeah.
But this is, I think it's awful. It's it's very difficult to make a breakpoint, and I know I have to. I was using PyCharm for around 2 years, and I really love the complete features of high-end IDE.
What were you using?
PyCharm.
Oh,
PyCharm.
Okay.
Yeah, this is a famous IDE for Python coding. Yeah.
I mean, for me, the weirder thing, to be honest, with Jupyter is just that you never know the state of your program, because you can jump back and forth, and it's like if something is in memory or which state it has, because, I mean, you can kind of pass it by the numbers, but for me, it's just not weird. But anyway.
Variable visualizer, Jupyter Lab. I use Jupyter Lab. This is the next generation of Jupyter notebooks. They have a plugin recently done by one of the fans of Jupyter. They made a visual visualizer for the variables. So if you have a matrix, you double click on it, and you can see the what is content. Yeah.
Do you know the name of it?
I will check it out and share it with you on Slack. Okay. No problem.
Thanks.
Something very funny that I did. I was running a script in Jupyter. A code in Jupyter, and what I did, I wanted to rerun the loop after that had finished. So I scrolled up and I shift entered again while the previous training loop was running, and I had no way to figure out what is going on until 40 hours later.
Yeah, that's one of the annoying things, is that you could have several things going and not know it. And wondering, why isn't this thing working? And then, you know, the only way you know there's an asterisk, I think, and after it comes to a number, then you know it's been done. And that is annoying.
Yeah. Yeah.
So we're done, and we'll see you guys next Saturday.
Yeah, let's just one thing. Let's just check we're in agreement in terms of, you know, what we do for the next stage. So I think Haida suggested, I just want to make sure I understand it correctly. So I mean, I think so. I haven't really been involved in the discussions, but my understanding is that what's suggested is these Kaggle competitions. So we focus on one live one, and then either on a weekly or bi-weekly basis we have the either text or image or whatever. But we have this one live one running throughout those couple of weeks, and the option for anyone to dip in and dip out for these old Kaggle competitions that might be either text or image or so on. Is that what we kind of decided? And then Haida's going to send out a couple of options. Have I understood that correctly?
I mean, there were a couple of options that I put up. One was the deep learning book by Ian Goodfellow, but again, it's too much math and everything. So in general, everyone sort of settle on Kaggle competitions. Now, the problem, I suppose, with live competitions might be that since we're on a public channel in our community, so we might be violating some rules. So we will have to be careful with that. But otherwise, I'm fine with the live.
I think there is solution for this problem if we team up. I mean, if we call ourselves this week TWiML group, so we can join together. But of course, GitHub
is there a limit to the team size?
Yeah,
I don't know.
It depends on the competition. Sometimes it's like 5 or 8 or something.
I see.
Okay. Isn't there a limit as to how many people could join?
Yeah.
Or no?
I mean, we could have like 1 or 2 teams, doesn't really matter. I mean, it depends on how many people are actually involved, and then just do private channels on Slack, right?
Yeah, for GitHub, we can use instead of GitHub, because you know GitHub is a public repo. You cannot make private. Well. But you can use instead of GitHub, there is a competitor for
GitLab. Yeah.
This is one, and the second that I used before
Bitbucket.
is exactly Bitbucket.
I'm a student, so I still have the private repos. That's the benefit.
Yeah, Bitbucket is limiting you until 5 team members if you have used the free plan. So maybe 5. If we are insisting on using one repo for every team.
The other option would be to keep everything open, and then because they say if you share everything with everyone, that's also okay. But then we kind of.
No, I don't think so. I think there's some legal stuff in there that you're not allowed to share stuff, and the everything open is for data sources, I think. So if you compete, and then you have to provide your extra data that you used. But I think this kind of a weird restriction on discussing it outside of your group.
People do it all the time because the kernels are available for every competition, and people kind of share the code and all that stuff. People share code with the solution.
That's true, yeah. I mean, maybe it depends on the phase of the competition. I wasn't really involved in detail, but Kai mentioned something on the channel.
But I think it will ruin the fun of the live competition. It's one of the exciting things that you are competing with others. If you share everything, then what's the point that you are doing a live competition?
The term is private sharing outside of teams isn't allowed. I'm not sure about the other legalities that are involved. So we'll just have to be careful with that for a live competition. And if we go with an archived one, we could go crazy in all sorts of ways.
Well, I think why they do that is someone would then accuse someone of stealing their ideas. So that's probably why they have some kind of restriction like that. Because then there could be a lot of bickering going on, like when a comedian steals jokes, you know, and all hell breaks loose. And so they may be just trying to avoid that little problem.
Okay, so I mean, I'm just trying to reduce the number of choices that we have so that when we do have to like vote or whatever, it doesn't become crazy. So, I mean, so just to recap, we've got this one live one, the multiple shorter ones with those different topics, which Ida's very kindly agreed to provide, and then that's it. Does anyone else have anything else that you want to add to that? Or?
Maybe rotating book discussion. I don't know, everyone says that you have to eventually read the deep learning book at some point. So I know it's too much math and everything, but
well, I'll tell you what. I mean,
you also mentioned that Jeremy did, right?
So add it to the list, right? And then you vote. And so if people want to do that, then that's fine. And if not, I think that's probably the easiest
agree. For anything that is officially decided, I think it should be done after a poll. So this is just suggestions from me or from others. Then we just make the polls and we decide after.
Yeah, so we'll have 2 weeks to kind of figure it out what to do. So I think this should be okay.
Mm-hmm. So let's take up the suggestions and we'll run a poll after some time.
Yeah. So just so we're clear, Haida. So one is the live competition. So I mean, this is for your options. One's the live, one's the ongoing Kaggle, and then I guess the other thing is also, is it going to be weekly or bi-weekly? I guess that's also something we're not sure about. But I think everything else we've kind of decided on. So it's only these three sort of factors that we have. Oh yeah, and then someone
find people to host.
Yeah. And that's a really nice suggestion also from Yuri about discussing anything. Well, first, if you can understand anything that came out of NIPS, and then then trying to figure out.
Yep.
All right. Okay.
Adios.
Thanks for hosting. You did a great job.
Thank you for joining me.
Yeah, thank you.
Thank you.
Thank you. Bye.
Thank you. Bye-bye.
Bye-bye.
Thank you. Bye.